Discussion keeps the world turning.
This is Roundtable.
Robots running and dancing and fighting and playing football and so much more. Well, it sounds like a sci-fi movie, does it not? But it is not. It's the World Humanoid Robot Games, a real competition that brings together machines from all around the globe. The events are equal parts impressive and awkward at times to watch. But why, if we think about this, do robots even need sports in the first place? And what does a robot on a track tell us about where this tech is really heading? Coming to you live from our studios here in Beijing, this is Roundtable. I'm Steve Hatherley. Thank you so much for giving us your time today. And for the show, I'm with Yushan and Yushun. First up, what happens when robots stop living in science fiction movies and start competing for medals? Well, apparently they need to run and dance and fight and play different types of games. The second World Humanoid Robot Games officially opened on August 22nd, bringing together robots that are being asked to do some surprisingly human things. And behind all the fun and slightly funny-looking competitions is a much bigger question about where humanoid robotics is heading. Are we watching the birth of a new kind of sport? Maybe not so much. How about a giant engineering experiment? Maybe a little. Or perhaps the world's most elaborate robot job interview. And I think in some sense, that is what we're seeing there. And why, as we ask some questions, exactly do robots need a sports competition in the first place? What is this all meant to be? And what can a robot running on a track tell us about the future of work? Lots of questions and hopefully lots of answers too, Yushan and Yushan. Good afternoon to you both. Yushan, this was a special experience for you because you were at the World Humanoid Robot Games.
Yes, this event took place in Beijing's National Speed Skating Oval, better known as the Ice Ribbon, and actually before I had experience of ice skating in that.
Oh, cool. That's cool because that's where the Olympics were held, right?
Yeah, some of the events were held in there. And the main competition runs from August 22nd to 26th over 5 days. The theme of the games is 致敬向未来. In English is racing towards a shared intelligent future. Remember the Winter Olympics theme is also like something towards a shared future. And now this one is more intelligent future. And compared with inaugural games in 2025, the scale has grown dramatically because this year, 666 teams are participating. More than 2,000 humanoid robots will competed. And the teams come from 6 continents and 16 countries and regions. More than 50 events, and the games will stage 1,300 individual competitions over 5 days. And the number of team is up 138% from the 280 teams at the first games. And the number of events has almost also doubled from 26 to 55, as I mentioned before.
A much bigger event. Were you in attendance last year as well, or this was a first time for you?
This is the first time for me to attend this.
That's pretty cool.
Yeah, and comparing with that from last year, since this is only the second of such games, there are, this year, 641 Chinese teams involved too, and that's representing 157 companies and 200 universities and research institutions with in total nearly 2,000 robots. And then there are 27 universities in China's top tier among China's top tier universities that are participating. We'll also hear how some younger robot trainers, if not robot operators, are if not already spotted on site, really manipulating the robots and doing all different kinds of sports too.
Yeah, then internationally, you've got teams from the U.S., from Germany, Brazil. They put together a 5-robot football World Cup team, or World Cup teams, into a national team, which is kind of fun. I guess the point of all those numbers is that this is no longer a small technology demonstration. This is becoming a really large-scale meeting point for all of the outlets that you just mentioned. You've got universities represented, robotics companies, of course, researchers, engineers, even the public, too, because the public can buy tickets and go and watch the events.
Yes, and, I was surprised by the amount of audiences, actually. The moment that I got into that venue is like It's quite occupied, to be honest.
Almost full? Cool.
Yes, and the whole thing matters because humanoid robotics is still quite a young industry. We're seeing different types of competitions in recent years, and a sports competition like this gives companies and also other developers something that is quite unusual, a standardized environment in which different technologies can be placed side by side and pushed to their limits.
Yeah, this is a chance for the companies to kind of measure themselves against their competition. They would be there doing their best, of course, but they could see other companies and what they're up to and what they've achieved and the mistakes that they've made or what their robots are making, and then it gives them kind of a good idea of where they stand within the market itself. All right, so what are the robot games, what are they competing in this year then? There's some really you've got your standard stuff that you see at the Human Olympics, but then you've got some quirky little events that measure their skills too.
Yeah, I think that's also the highlights, if not the smartest designs for this year's games, because this year all of these events are divided into two broad categories. So let's look at it. Look at what the robots are doing from that perspective. So the first one is more or less the more traditional and expected ones are the competitive and athletic events. So these, well, there are traditional ones and of course newly added sports for the robots to try out as well. So these are designed to test their raw speed, physical power, endurance, flexibility, physical coordination, etc. Through sports events like, for example, track and field. Robots, they compete in the, different length. There are the 100 meters track, the 400 meters ones, the 1,500 meters ones, and also the 4 plus 100 meters relay under fully autonomous modes with strict finish time limits. And then there are also ball sports, including football and soccer. And here's where things get really interesting because there are different games assigned to, for example, U19 3 versus 3 or U19 5 versus 5 medium size, meaning that U19, as you probably know, that is a common term for a lot of different sports in ice hockey and football.
Under 19.
Under 19 years old. So now we're not talking about the robots under 19. We're talking about the operators. That are actually teenagers.
Students, yeah.
Students from schools.
Pretty cool.
They're operating robots and playing 3 versus 3 football games.
I saw elementary school students.
Elementary school
sitting, aside and controlling these robots to playing football.
It's pretty crazy.
And they are quite the same height, to be honest.
The 100-meter dash, the world record was broken. Set by Usain Bolt from Jamaica back in 2009, 9.58 seconds, right? The robot that ran in the 100-meter dash broke that record set by Usain Bolt, this time 9.39 seconds. You got to witness that, Yushan.
I witnessed it. Wow. When you say that, I didn't realize that, wow, I witnessed something that breaking the world record. But yeah, that moment, everybody at the venue was just shouting and standing up and shouting for that specific robot. But it was not, to me, I was not that, 100% or 120% surprised because we've seen some of these robots
run fast
through that like half marathon of robots. So at the moment, of course, when we see the numbers, we were excited. But when we think back a little bit about a robot just run probably through hours with that speed. Wow.
The end of the 100-meter dash was almost more dramatic than the race itself because they had this, did you see the video?
Yeah.
They had this padded blue wall set up because the robots don't slow down. They just keep going at full speed and then they crash into that. They look like crash test dummies at that point. Hit the wall and break and fall down and they get carried off in a stretcher.
I think it should be, or it is one of the indexes of how these robots can manipulate itself, because some of the robots, I think they designed them to slow themselves down at the finish line, and some of them just crash onto the cushion
straight on.
And so of course, we know that they want to reach this level of the fastest speed when they reach the finish line. And another one is we can also see they're designing to be more, the whole design is more completed.
Some other things they were taking part in, free sparring and combat, so different weight classes for that, apparently. They did some tug of war, which is always fun to watch. Some weightlifting. Did you catch any of the weightlifting?
No, but I witnessed the combating.
I watched some of the weightlifting. It was like a power lift, the videos that I saw. And from what I saw, they weren't attempting to lift anything that was particularly heavy. But I think it was more about the action of bending down, picking something up. It looked like a person in a gym, and then pulling it up to their chest and then pushing it up above their head. Some successful and some not successful. And the not successful ones actually looked like a person struggling, got it over its head, but then started shaking, almost out of control, and then dropped it and kind of stumbled forward, and then just crashed on the ground.
Because they always adjust their movements and the strengths they're using simultaneously when they're lifting these kind of things. I think that is also one of the reasons that they are being more like human, as we said.
So that was kind of on the athletic side of things. But then there were some scenario-based competitions as well. And not everything at these games is meant to emulate something from the Olympics itself.
Not really, because, this is where I find it's perhaps more attention-grabbing during the entire game. That's the second category. That's the scenario-based competitions, because these events, they are designed to test if the robot can actually do a job. So by scenario-based, we are putting them into almost like a real-world applications, like, for example, household cleaning, hotel service, manufacturing, and healthcare and vehicle charging. They are meant to or expected to do or practice really delicate jobs like dexterous hands. There's a special competition under that title, and what they're required to do is to, for example, tweezers and beans.
Yeah, this is where I said that, some of them were a little bit quirky, a little bit different, the things that they were asking them to do. Yeah, tweezers and beans. So this is where the robots had to use tweezers like you would use to, pluck your eyebrows or something. They had to use the tweezers to grip and then deposit these soybeans without dropping them. And obviously that is being done to check whether the robot is able to do different things like, apply different amounts of pressure and look at very finite movements. Using tweezers is not an easy thing to do. So this is one of the more fun ones.
To actually locate one single soybean, I have to say it is quite complicated and sophisticated when you have to design the whole system for a robot to do that, even for a human. If you are using, because there are games like we use two tweezers or chopsticks to pick up the soybean.
Yeah, right. Yeah,
it is hard for a human to do that.
They did some powder weighing. That's where they scooped powder with a spoon and then monitored the scale readouts to reach a target weight. And the goal there was to do it without spilling any of the powder that they were transferring. Bottle opening and cap prying, they did that. They did toy block building, tool assembly, nailing and fixing, unboxing and unpacking, cable connection and vehicle charging. So there was a lot of different types of those types of events happening too.
There's also one competition that's kind of happening, if not more than one, that's happening in real environments outside of the stadium. For example, the library competition. I was wondering what a library competition is like. So apparently they put robots to complete tasks like organizing and shelving books in a real school library. That library that this competition carried out at belongs to Beijing number 80 High School in Wangjing District in northern eastern side of Beijing. So we see how real and practical these whole games are designed to be. And I think that tells us a lot of things.
And we listed some of these, real scene or scenario-based competitions. It sounds like something that may happen, and we've already done with a lot of these automated machines and mechanics, right? But the thing, I also asked some of the practitioners and competitors, and why do we need robots to participate in these kind of competitions? And the answer is because most of them, a lot of them, are running by themselves. They're not controlled by human.
Autonomous.
Yes.
Just like the 100-meter dash, you said.
Exactly. So they detect with their cameras and sensors, and they make movements and actions by themselves, and they know and they judge and they decide what to do. I think that is the biggest difference, and that's how they can be used maybe after they are, practiced enough to be in our real life.
Sure. Some of the events were done for very practical purposes. One highlight, I think, was the firefighter tests.
Yeah, I can't believe they're already doing this, because you will think the distance between robots doing anything that's related to saving an actual human life in a fire hazardous, for example, that's like still far away from our life, but they're already testing out, and which is, of course, one of the most striking examples during the games this year, the firefighting scenarios for robots. So inside that competition area, the robot faces smoke, obstacles, and simulated fire. It's not real fire, but they can try it out in the fire and see if they can actually inspect, for example, hazardous materials. If they can close valves and search for the source of the fire, etc. And I believe the robot's biggest advantage is quite obvious, because they do not need to breathe, and therefore they can be immune to stuff like heat and smoke and dangerous physical environments like fire. That's very, very fatal to human. But that competition also reveals the current limitation. Like I mentioned, we still think there's a distance, and that reveals through the robots that are still relatively low in the movements and how they are reacting towards different like sudden cases whenever it occurs.
Yeah, and something as silly as picking up a soybean with a pair of tweezers, as we mentioned, it's not really about picking up a soybean with a pair of tweezers. It's about the dexterity of being able to do those kind of minute movements within a hand and holding objects and pressure, as I said before. But why make robots compete at all? I wonder why this kind of platform for it.
This has always been my main question when I was attending to this event. And just, think about human athletes. An athlete does not train only because winning a medal is useful. Competition gives them a clear target, standardized rules, measurable performance, repeated trials, comparison with other competitors, and also immediate feedback.
The robots kind of get the same thing, I guess.
Yes, and a robot company can say, okay, our robot is highly capable, we can do this, we can do that. But a competition asks, okay, can it complete this task faster and more accurately and more reliably than the other robots? And that difference is enormous. And I think that is the moment that I wanted to ask some of the competitors about this question. Why do we need to make robots compete in such kind of games? So I brought this question to some of the competitors, and the first one is Pei Zixing from the North China University of Technology team. She explained some of the goals her team is working toward.
We use martial arts, for example, to adjust certain parameters so that the robot can really demonstrate the sense of power and rhythm inherent in martial arts. When the robot completes a series of movements, the first thing is that this can have commercial value. It can be used for demonstrations and commercial performances, which is a very good application. Second, through these different movements, we can adjust the utilization of the robot's joints, making it more flexible the next time it is used. This also gives us more cases and scenarios for subsequent testing and debugging. Ultimately, these scenarios can help bring robots into our daily lives. Whether it's charging, gardening services, or other tasks, so that they can genuinely help people in their everyday lives.
And I also spoke with Zuo Jiaping, who is the co-founder of LinkerBot, which is a Chinese dexterous robotics company, and her team took part in every, what we mentioned, real scenario event.
A skill like screwing in a bolt is a skill in itself. Once that skill has been properly trained, it can be used in many different scenarios. So all the skills designed for this competition can potentially be reused in real-world applications in the future. For example, you saw the robot band yesterday. What it was doing was essentially playing drums and piano. The system's ability to monitor the force used to strike or press something can also be applied to many industrial or everyday scenarios. These skills can be developed into a kind of skill package. Different skills can then be recombined to create new tasks, making it possible for robots to complete longer and more complex tasks. So, training these skills isn't simply about completing a one-time competition. Once the individual skills are broken down, they can be reused across many other scenarios.
That's a good point, I suppose, because, Yushan, you mentioned the library before where the robots were having to pick up books and move them and put them on shelves and kind of complicated movements. But the point is that every library around the world is going to be pretty similar, right? So if you learn skills that can be applied to a library, well, once you've learned it, then you've learned it. Hotels, too, I assume would be pretty similar in all parts of the world. So the skills that the robots need in a hotel, once they're learned, then they can be applied to any robot anywhere for that particular purpose. And I guess that's kind of an advantage of working with robots versus working with humans, is that once you train one robot, you've kind of trained all the robots.
And yeah, as we just mentioned, like if you trained the whole package of the skill when the robot is in the library, maybe put the same set of skills into a factory, into the supermarket shelf, they can do quite the same actions. So I think this is why the competition is about. So you can have a measurable and also standardized rules, making the whole industry to understand what is actually going on, to see the company's position, to see the team's position, and then to, I think, exchange experiences on what the whole industry is doing.
And back to your question, which is on like why they have to compete in the first place. I think it's almost like this is designed to let them make mistakes, as many as possible. The more, the better. Because this is a real testing ground for all the different humanoid or not robots from all different backgrounds, lab or companies, to just have fun together, if not compete with each other. And there's this whole feedback loop that the companies and the developers are hoping to kind of wrap up through this whole events. We set up a real world task for you guys, and then we see failure, we see you trip, we see you run into walls, we see you break in two, and then we collect the data, and then we run the algorithm and see if there's any room for improvement, and then we put that new development back to your hardware as an improvement, and then we test you again. Eventually, this is how do I describe it? Like an uplifting spiral of progress that eventually end up as a deployment that we can actually use in perhaps next 5 years.
Yeah, that's a great way to put it. Is that every event like this, there won't be any regression. Each subsequent event will be something better or more successful. Further applications of what the research has led the engineers to. So here, this year, at this 5-day event, it's just kind of a snapshot of where we are right now. So Yushan, to be there, I'm sure you saw lots of like successful things, but also some unsuccessful things too. You saw one robot split in half and catch on fire, did you not?
Yeah, because they were running so fast. And we were putting really high hope on that one. But I think it is probably 50 meters long, and it started to, crash. And then because each one of these robots are quite heavy, and then probably because of the heat, because of the weight, and it started to crash into two and sparked a fire on itself. And I have to say, a lot of audiences just feel sorry for the robot.
Yeah, human reaction, right?
And I think that is one part that these companies kind of also anticipated, because if they want that robot to perform at the full speed, there is also a risk that it will collapse.
So, yeah, and those are the challenges, right? Those are the difficulties, but the difficulties and the challenges shouldn't be seen as a negative thing. It's just a step towards their end goal, right? So when we see a robot crash into a wall and fall onto the ground and carried off in a stretcher, we might look at that as a failure. Or if we see a robot split into 2 or 3 or 4 different pieces, we might look at that as a failure. But really, this is just learning what works, learning what doesn't work.
Yeah, and as Yushan just mentioned, the data, no matter it's successful or unsuccessful, the data that they collected is quite precious, and that is maybe also one of the reasons so many teams want to participate in, because demand for embodied AI training data has grown dramatically. That's also backed by some of the practitioners in AI data training things. That's Li Yao, co-founder of Noitom, a company providing data acquisition and motion capture solutions for humanoid robots. Last year, customers might ask for several thousand hours of data, and this year demand has risen to hundreds of thousands of hours, with some customers already expecting data volumes in the millions or even tens of millions hours. And at the same time, data collection companies themselves cannot produce enough data alone, because Li Yao also said that its own production this year is in the hundreds of thousands of hours, with plans to reach several millions hours next year.
Yeah, they always talk about data collection, and that's, again, if you wonder why put on an event like this, that is the point, is that they want to get as much information. Data might be a confusing term if you don't really know what the context is. Data is just the information. It's the feedback from what the robots are doing. What did they learn from their experience, either through success or failure?
I remember we talked about how some companies, they run out of data and they're so desperate that they need a real human to carry out some household chores as a way for them to collect data, so that they can push the human data back onto the robots to train them.
Exactly.
And also, speaking of the different kind of challenges and also the challenges of data, I also put this question to Zuo Jiaping, we mentioned before, the co-founder of LinkerBot, and as expected, she highlighted some of the challenges surrounding data.
Based on our initial assessment, I think data is currently one of the biggest challenges in training models and rapidly improving their general purpose capabilities. Our sensors and system designs are also constantly evolving, but data accumulation is something that cannot be achieved overnight. That's why, at the national level, there are already plans and projects to establish practical training and testing centers. In fact, different regions are now building their own data collection and video centers. Personally, I have a suggestion. Since these facilities are being built in different places, could we make the data available through a shared platform? That way, when different teams are training robots, they don't have to duplicate the same work. If one team is collecting data for household scenarios and another is collecting data for industrial applications, some of that data could potentially be shared. So, I think data is an area where we need a coordinated national strategy, with top-level planning at the national level. First, we need to establish national standards defining what kinds of data should be collected, what makes data useful, and how its quality should be evaluated. We need standardized technical solutions and systems for collecting and managing these materials. Second, the regional distribution of these facilities should be based on local industries and actual local needs, with specialized data collection carried out accordingly. Third, at the national level, There should be a public platform that can integrate these different data sets and make them available, to a certain extent, to organizations and users who need them. Some basic data sets could be made freely available, while commercial data sets could potentially be offered for a fee and operated as a commercial service. That would allow us to build a data ecosystem based on sharing and avoid unnecessary duplication of infrastructure and data collection. So I think establishing standards, developing a data management system, planning the regional layout, and determining how the government should manage and operate the system are all urgent issues that we need to address right now.
Yeah, it's great points. I mean, it's almost like the same conversation we have when we talk about the benefits of open source technology.
Yeah.
Right? If you take these data sets and you make them open source, I don't even know if that same term would apply there, but if you make it available to everyone, like she said, it'll just make the whole process that much more efficient, right? And industries will move forward faster together. Now, the other issues that she mentioned about, a coordinated effort, that's actually happening. China is really quickly building supporting infrastructure like embodied intelligence training facilities. And at those facilities, that's where robots can practice over and over again some of the real world tasks that we've been talking about thus far. And it's kind of, it's addressing that need that she said exists, where you have to have the places, you have to have the locations for all of this training to take place.
And this is the policy and the encouragement that officials are trying to do. That's from a 2026 report from the China Academy of Information and Communications Technology. By the end of June, China had more than 70 operational embodied intelligence training facilities, with another 46 under construction or planned. And these facilities have already spread across 18 provinces, municipalities, and autonomous regions. And this measurement is also encouraging all the regions nationwide to build up more facilities like this to help the companies to have more data and trained things.
So what was your main takeaway then, Yushan? Were you impressed? Were you blown away when you were there? You saw a lot of different things, some successes, some failures. What was your overall assessment?
I have to admit that at the moment we watch robots, doing combating, running that fast and jumping that high.
2.88 meters, by the way. We didn't even mention that, did we?
Was that 2.83 or 8A? I can't remember. But
anyway, that robot.
For high jumping?
Did you not see
Wow.
that video?
Jumping.
It, from just standing there, not like running and then jumping like humans do the high jump at the Olympics. It was just standing there, and then all of a sudden it launched almost 3 meters
Exactly.
up into the sky. It did the splits.
Yeah.
I think so it could clear like a bar, right? So it could clear like a certain level. And then just came back down and landed like a reusable rocket. It was crazy.
And the gestures and the actions, it's so flexible and so smooth. It feels like they have all of these, elastic cushion or something on their feet. And it finished so perfectly. It feels like it even floated in the air for several seconds.
Yeah, well, I'm expecting to see new memes coming out in no time saying elegance.
Yeah, so for these kind of moments, I was 100% astonished. But for some of the things, because I was surprised probably half a year ago for the half marathon of robots. So this year, when I was seeing the same kind of speed or competitions, I think, this is what they can do. And maybe we're expecting more of this.
Some of the criticism about the task-related things is that the robots were
real
moving...
scenario things.
The real scenario things is that the robots were moving a little bit slowly. But I mean, let's go easy with our criticism, right? We're talking about robots that could potentially take the place of firefighters so that humans don't have to put their lives at risk. We're talking about robots that we can have in our homes to help us with our daily tasks that are too annoying for us to do, and working in factories and working in hospitals and all of these different applications. I'm perfectly okay with where they are now, and it's moving forward so fast that I'm already excited to do this report in 12 months' time here on Roundtable and see where we are then.